So yesterday we initially saw about we just revised the earlier day's session. That was about what goes in a Java file and some kind of a structure for the Java file. Okay, fine. And then we started with the data types. Okay, so data types in Java. And so any questions from the earlier sessions?
So can you maybe scroll up?
Yeah, sure.
At data doc
Data.
dot yeah.
The Javadoc command you want to know about?
Yeah,
Okay, so it was on the earlier day, right?
yeah, earlier.
Okay, so Java, and here is and you could go through the video.
Actually, sir, actually due to some office tasks, I didn't get chance to go to that video. But I go through this notepad file. In that there is one mention com dot doc something kind.
Com dot Java C Java. I think I'm not written about the Javadoc command, but yes, we have a command called Javadoc, which I had used earlier. Okay. Module. Okay.
Yes, module, sir, that is 176 line. Okay. So, module com dot class of Java dot intro. So, what is this? Is like just a program or like is something like that?
Okay, fine. Now, fine, we understand one thing that these are all data types, right? As far as the classes, interfaces, the other 5 items are just some kind of a data type. Okay, fine, that's what we understand.
Yes, yes.
Okay, fine. So, okay, now I'll just show you. I'll put the structure here. Okay, fine. Anyway, it's something like this. Earlier Java was only dealing with those 5 types. Okay, but anyway, depending on the prefix, if there is a common prefix for a set of classes, okay, or a set of types, then it used to be called as a package.
Okay.
Okay, fine. So okay, so we could put all those data types and put them into various kinds of packages. Okay, fine. And then we had so many packages. Okay, even the Java library, the core library of Java. So when you install JDK, fine, and you get one basic library for so many classes interfaces which are part of the Java library. Okay, so this number increased to such an extent, right, that it was decided that we should have them divided into modules. Okay, fine. With the idea that not everything in the API in this library, entire library, is being used by your application. You write small application, each application uses only some part of the library. Okay, fine. So yes, looking at the dependencies, which class depends on what, which, or rather at the package level itself, these packages were then classified into modules. So module definition was introduced at a later stage. This has been we call it as modularity. So modularity was introduced from Java 9. Okay, so this is from Java 9. Okay, fine. So again, another idea was that yes, you can always, if you have at runtime, right, for fine, you install JDK, you have the entire the library, that is fine, the core library exists. But for once the application which you have built, right? When you have to distribute the library part, you don't need to distribute the entire library. Okay, so you have the only what are the modules which your application needs, and if those modules have further dependencies on other modules, and so only those modules collectively are needed for deploying your application. Okay, and so this is the purpose, so that a huge library, something which can go into a gigabyte of thing. No, it's not gigabyte, but really quite large, okay, to be distributed somewhere. Fine. So from that purpose, the modularity was initiated, and in Java 9, the modularity was first introduced. But the thought about modularity, okay, was initially there right from Java 6. When Java 6 was there, yes, this thought was already there. So a lot of work has gone into this modularity. Okay, so fine. So it's the structure would go like this. We would have a module. Okay, so at the top level would be a module. Okay. Next to within the module, you would have packages. Okay, so package is part of a module. Okay, and in the package, you would be having the types, classes, interfaces, and those 5 types, right? The 5 types, I'll just put as types. Okay, and mainly the classes, interfaces, enums, annotations, and record. They are actually so if I look at enum, it's a kind of a class. Record also another kind of a class. So they fall in the category of class. Annotation falls in the category of interface. And so broadly, you may just say, okay, classes and class type and interface type. Okay, fine. So this is the structure, right? The core structure module. So if you are looking at a module definition, what can go in a module definition? It's for defining the dependency. A module can say, so when a module is there, it will say, oh, this module is dependent on other modules. So yes, the dependent modules would be mentioned in the module definition. Well, I require this. Okay, and this module needs other modules. So at a module level, I'll say this is what I need. Another thing, from the privacy point of view, okay, a module will also mention that you might be having so many packages in a module, right? But this module can say, no, I don't want to expose all my packages to everyone. Okay, it can say these are the packages which will be available outside this module. From the packages which I have a list of packages which I will be exporting. Okay, and so it says it exports these packages. So exports followed by a list of packages. So those are the kind of things which go. We have kept it blank. Fine. So this module info.java, what would have gone here? It would have been mentioning that, oh, what are the modules I require? Okay, and what are the packages which I'm exporting? Okay, fine, clear?
Yeah, fine. Yeah.
Okay, yeah. So any other questions? Yeah. Okay, fine. Then we'll continue with the data
Yes.
types. Okay.
Yes. Okay, fine. So yesterday, yes, we had started with the primitive types. Fine. I'll just list. Fine. And about the primitive types, yes, we'll say, okay, byte,
Okay, let's mention the, okay, this is, I'll say type followed by size. Size we can write in bits or bytes. Okay, it's an integral type or so signed and unsigned, those kind of things. Okay, I think that we have already mentioned, right? Size we know. And okay, so another thing is yeah, so yeah, what would be the range? I think these are all signed types. So what's the range? 2 to the power of, what is n here? For a byte it is 8 bits. So what is n? Okay, the range is from negative side, minus 2 to the power of, we have 8 bits, but it is a signed type. 8 bit signed type, the most significant bit is a signed bit. Okay, and therefore this will become 7, right? From this, right? So minus 2 to the power of 7 up to 2 to the power of 7 minus 1. Okay, and which becomes minus 128 to plus 127. Okay, fine. So same way, short, right? So they have the ranges. Fine, now you can know, right? Minus 2 to the power of 15, 1 bit for the sign. 2 to the power of 15 minus 1. Okay. Int also similar, right? These are for the signed types, it will be like this. Okay. Okay. So long would give us 2 to the power of 63 to 2 to the power of 63 minus 1. Okay. And these are for the integral types. Okay. For the floating point type, okay, there's one more integral type called the char type, but this is a unsigned type. Because it is unsigned, the range will be from 0 to 2 to the power of 16 minus 1. Okay, fine, which is nothing but your 0 to 65535. Okay, short is also, yes, you can write this. This is from minus 2 3 to 32768 up to okay, fine. This would be a 10-digit number. I'm not writing what it would be. Fine, you can find out. Fine. It is some 10-digit number starting with 2. Okay. So 2, 1 and something, or 2, yeah, I think. And this would be a 18-digit number. Okay, so just fine. Okay, fine. Okay. And so integral type. Now in the integral type, at the core level, right, as far as Java is concerned, uh, uh, if you deal with any numeric or arithmetic operations, right, okay, or dealing with a numeric value, we have got what we call as literals. Fine. So we have literals for the type int. Okay. So we have the literals are available for int. Okay. So for int, how do we write a literal? Yeah. Okay, now I think before I go into that, fine, literal means constants, right? The constant, a value, fine, when you write a value. Okay, so now before I go into this, I'll just ask a question, because this is again something which works exactly like in C language. Okay, some of the things which I'm asking here. So tell me whether this is true or false. Double equal to is for to check the equality. So is this true or false? And we have this is true or false. Second one. What do you think is true, and which one is true and which one is false?
Second one is false.
Okay, so your answer is 7. Second one is false. Okay, and see this, whatever I'm mentioning, okay, it's even true for C language. Okay, it's not only for Java. Let's see this. Okay, fine. So let's observe this. Okay, what happens? Okay. We can test everything with JShell, right? Small things can just simply be. Okay. So here, 1 2, right? Double equals 0 1 2. Okay, so you can just put any expression, it will give the value for that expression. It says this is false, and this it says is true. Okay, and that's again true for C language. Okay, fine. Now let me put one more expression, and then I think you will be able to realize. Okay, suppose I write like this 0x1 2. What do you think, true or false? This you will be immediately be able to answer. This should be true or false. 0x, what is 0x? I think 0x you would know. If I start with 0x, then what does it mean? Then it would mean that we are writing in hexadecimal. That this literal value is in hexadecimal terms. So in hexadecimal, this would be 16 plus 2, 18 basically in decimal terms. See, left hand side is decimal, the right hand side is hexadecimal in this case. So now can you guess for the earlier case? Okay, so this would be false. But I could have always written 0x 0c, right? And that should be true. C is 12. Yes. Okay. Fine. So what is the earlier case? When you start with a 0 and not 0x, then we are specifying in octal. Okay, fine. So if you start a token, any token, right, and if it starts with a 0, it's understood that this is a numeric letter. Okay, if it starts with 0 and followed by some digits, yeah, 0 followed by some digits. Okay, fine. In that case, yes, it's a octal digit. It's understood that it is octal. Fine. Anywhere in the code, if you write somewhere like, okay, int a equals, and suppose I try 0 1 8, what will happen? 8 is not a valid octal digit. Okay, so this should be an error. That's an error. Okay. Yes. Fine. So when you start with a 0, the compiler says, oh, this means it's a octal value. Okay, fine. We have 0x so that we can specify a value in terms of hexadecimal. Fine. And we can also use, now this is from Java 7 onwards, okay, where you can use 0b for writing your number literal in a binary form. Okay, so here you can only use zeros and ones. Okay, so yeah, that should be true. Okay, fine. 1100 binary would be 12. Fine. So fine. So to write your literal, right? Okay. As octal decimal. We should have started with binary, octal, decimal, or hex. Okay, hex is hexadecimal, right? Short for hexadecimal. Fine. So fine. When you start with a 0, when 0, and it can be followed by octal digits. Okay. Okay. Same way, 0 B. Okay. Fine. And then what you write here, okay, if X here, okay, X can only be 0 or 1. And if you start with 0x, your y here can be from 0 to 9 and followed by A to Z. Okay. Okay. When I say A to Z, it could be in upper or lower case. Fine. And so it can be either in upper or lower case. Right? So you then you are writing in not Z, sorry, F. Okay. A to F. When 0 to 9 and A to F, that's what is usable for hex. When you start with the 0x, that would mean this. Okay. And if you start with anything from 1 to 9, then it understands it's decimal. Okay. Fine. And simply writing a 0 alone, okay, it doesn't make a difference whether it is octal, hexadecimal, or decimal. Okay. Fine. Fine. So this 0 is considered as decimal by the compiler. Only a single 0. Okay. Fine. Not followed by any digits, and it's a decimal. Okay. And so literal for integral, when I say integral types, right, we understand this integral type would be either, okay, this is for the type int, okay, type is int. Okay, so for all of these, the by default, right, okay. Fine. So it would be allocating for those values, it will be allocating 32 bits. Okay. If you want a value of type long, okay, fine, we suffix with L lowercase or L uppercase. Okay, it is always preferable to use the uppercase L, fine, and not the lowercase L, because maybe due to some phones that lowercase L may be mixed with the digit 1. Okay, to avoid that confusion, normal preference is to use capital L. Okay, fine. See, I was mentioning it's a 10-digit number starting with 2 1 something. Okay, so here, for example, if I say int a equals, and I'm writing a letter 5 digits 6 7. Okay, I'm just trying to assign this into a. What do you think? What will happen? This is not starting with it's more than 2 1. That means it's outside the range of int. That should be an error. Okay, fine. So this is an error. Fine. Okay, even if I say, oh, let me assign into long type, it's an error, because this is the value. The token is identified as a literal, and this literal says, okay, oh, this is not a valid literal. And if you wanted, you could have done capital L like this. That's fine. Fine, clear? So for literal for the long type, fine, we have to suffix with upper or lowercase l. Okay. Then for the floating point types. Okay. Fine. So this is for the long type. Okay. One more integral type remains. That's a char type. Okay. So for char type, okay, equals, you could mention in single quote. Okay, you could mention, we know this Unicode escape can be used anywhere, right? So it's not only here. Even if you don't want, if you know the hexadecimal value for the single quote, you may not write a single quote. Okay, because that anyway is interpreted before it tries to understand what it is. First thing is to convert into Unicode. Okay, fine. So if you know the Unicode hexadecimal value for the code point of single quote, you won't write, you may not even write a single quote. Okay, then also it's fine. But put the equivalent Unicode escape. Fine. So Unicode escape, we know about it. Okay, here we can use \u, and you could put any value, but you know, backslash always has a meaning inside in a character literal. Okay, so we have two kinds of character literals: a character literal where only a single character is mentioned, okay, as in the previous case, or or we call it as a escape character. So backslash is a escape. Okay, backslash means, oh, it is some escaping. Fine. So it's not to be considered as backslash, but then you can use either, there are limited things, B for backspace. Okay, this is for backspace. Fine. For example, if I say string, I'll have to show it with the help of a string, because char type is only single character, right? So if I say string a equals, or you might even print it. Let's print. Okay, let's say system.out.println. Okay, and we are putting okay, back, and then we are saying \b. So this is one single character. What is that character? It's a backspace character. Okay, if you look at the output of this, what do you expect? What should it be printing? See, after k we had a backspace. So what has come out is the k has gone. Okay. So we have \b. Okay, so okay, let's see. Here I'll put it. when the char value may be given as single character or using escape character. Okay. Examples of escape character. Okay, so what are the examples? \b. Okay, this is for backspace. \d, no, not d, \c, /r, yeah. This is for new line. Even before this, there's a \f for the form feed. Form feed means new page. Yeah. \r is for the carriage return. Right? Yeah, mainly this is what we normally have. And then we have a few things more, because if we want to use a single char, right? So you can write, or we want to specify a \. So this is for \, single \. Okay. We can use single quote. We can use double quotes. And so these are some of the common escape characters. Okay, so within single quote, this is what you could be using. Fine, when it is a escape character. Okay. Fine. So yeah, escape characters are fine. Fine. So char literals are okay. Fine. Within single quote, you can write those. Next thing is, okay. So integral is fine. Fine. As far as literals are concerned. Okay. Fine. Ranges we know. Now for the floating point type. Okay. So floating point types are float and double. Yeah. Okay. So okay, just one more point. Okay, let me finish this float and then we'll look into this. So by default, right, in floating point type, how do we specify literals? Yeah, how do we specify literal? We will use something like, okay, example. So if I say 12.5, then what is the type? Double. Okay. If you wanted to have a float, F. Upper or lowercase f. Okay. Fine. Okay. The suffix of d is also available. Okay. Someone could, for example, say 12d. See, there's no decimal point or anything. But then, oh, this we are saying it's of type double. Okay. Fine. Fine. So if you don't mention d, yeah, here, for, but you have used a decimal point, it assumes this is a d, double type. Okay. So fine, writing literals for the floating point type. Literals for strings, string literals. String is a class. Okay, it's not a primitive, but I'm just for the literals I'm mentioning here. Okay. Okay. Even going before literals, I think string literals. Let's look at the Boolean literals. Boolean literals. Oh, there are only two literals for the Boolean type. True, fine, and false. Okay. For the string literals, yeah. What are the string literals? How do we write a string literal? In double quotes. Okay. Okay. Fine. This is what we know, right? Fine. For example, okay. Fine. Another thing which is from Java 15 onwards. Okay. Okay. So from Java 15 onwards, we can use text block. Okay. Fine. By using triple uh, three double quotes. Okay. And for example, you may, okay, but when you start three double quotes, they should be in a separate line. Okay, so put the rest of the things in the next line. Okay, so here you could put a lot of text here. Okay, and for example, someone wants to specify a JSON, right? He'll say, okay, I have a JSON object. Okay, fine, and maybe the idea is even someone says, okay, I have a lot of HTML text. Okay, and I want it to be formatted in this manner. Okay, so all these new lines, everything will be considered. Okay, fine, and three triple quotes, and that's it. Okay, so this indentation, everything, new line, everything is part of the string. Okay, we won't have to say backslash r backslash n because there's a new line. Fine, carriage return new line. So whatever as it is, literally it will be taken. If you want to use something like this, okay, okay, this head has a double quote. Okay, you can use. Okay, fine, and so you may write like this. Yeah, so this all will be taken as it is. We don't need the escaping for double quotes. We don't need this. Sorry. Fine, we don't need that backslash double quote. Okay, fine. Same way for the end, we are not saying backslash or backslash. Just put enter. That's it. So this is allowed. We call it as a text block. So this is text block, which is in triple quotes. This is also a string literal, string constant. Yeah. And so you could include, we don't need escaping. That's the main idea here. Okay. And any indentation, they'll all be as it is. Okay. Okay. So string constants, I just wanted to show this text block. Right? So we have considered string is not a primitive type, but here I have considered the string literals. Fine. So literals for the primitive types is fine. We know the ranges for the primitive type. Acha, for float and double, oh, there are many interesting things about float and double. Okay, so for that, again, let me ask a few questions here. Okay. There are some special values which I would like to highlight. Again, understand this is for the float and double and not for all the numeric types. Okay, suppose I write like this, double a equals 75. Of course, we can put a 75, right? And we'll say double B equals 0, and someone says let's have double C is equal to A divided by B. What do you think is going to happen? And I'll copy this for another reason. Okay, maybe I'll test that later. This one so that you can answer correctly. Okay, and this is valid. Yeah, I mean compiler wise this is valid.
Yes.
Okay, fine. This will also compile. This will also compile. Okay. What about when we execute this kind of a code? What will be the value in string? Yeah. Yeah.
It's showing like exception.
Yeah. Okay. So this is saying exception. Fine. So this is an error at runtime.
Runtime. Yeah.
What about this case? Is this an error at runtime?
Yes, it's error at runtime.
This one. Okay. Let's try it out. What should be the answer? What do you think should be the answer? Mathematically.
Arithmetic operation exception for first. No, second that same exception.
Okay. Let's do this. Yeah. What do you think? You know maths already, right? So in mathematics, if you divide by 0, what should be the answer?
0.
Huh? Anything divided by 0 is? A positive value divided by 0 is?
0.
Huh? In maths, a division by 0 results in?
Again, it cannot be divided by 0.
When looking at mathematics, it's an infinity. Yeah, we have that, let's put it as minus of A, right? Divided by B. What do you think? We actually don't need this, but I've just put it for the sake of it, right? So this would be a negative infinity.
Okay.
See, if I do the same thing for the int type, it's going to say arithmetic exception. Yeah. Right? Why? Because I don't have an integer value to show you an infinity. Okay, with double and float, the floating point type. We are following the IEEE 754 standard. We have a way of representing infinity. Okay, when there is a way of representing infinity, see for float and double, how is the okay? Let's check this here. Okay, see for float and double, what exactly happens? They use, see, we got only 32 bits, right? Or maybe 64 bit. What is done in this case, the most significant bit here is for the sign. If it is 0, it is positive, it is 1, then it is a negative value. Then we have some bits here. This is for floating point types only, okay? Fine, which are known as the exponent bits. These are for the exponent part. Fine, exponent can be negative or positive also, okay? And then we have here, we got bits which are for the significant. IEEE 754 calls it significant. You may call it as mantissa. Mantissa in exponent form for numerical values, floating point types. Okay, so there is a mantissa part which is maintained in this bits. Okay, so we have a mantissa which is maintained in the following bits. Okay, least significant bits are for the mantissa part. Before that, the most significant bits are for exponent, and the leftmost bit, the most significant bit here, that is for the sign. Okay, fine. So this is how floating point values will be represented. IEEE 754, this is what it does. So what happens here is something like this. What they have done is they have said, okay, if we have all the I think it's all the exponent bits as zeros. Yeah, if this is all zeros, if this is all ones, yeah, if all the bits of exponent are 1, then it says we are not going to be representing this as a finite value. This is not a finite value. Okay, fine. If all the bits in the mantissa part are zeros, when we have all ones in the exponent, all mantissa bits are zeros, okay, then this represents an infinity. Positive or negative will be decided by the sign. So we have representation for positive infinity, we have a representation for negative infinity. Okay, now my question is, what is 0 divided by 0? Yeah. Positive infinity would be a positive value. What is 0 divided by 0? Okay. What will be this when I put b divided by b? Yeah. 0 divided by 0. In maths also you can, and see whatever I am showing here, okay, is also true for C language. It's not about Java. Okay, this is because we are following the IEEE 754 standard, which most of the languages, also all the languages for the floating point types, and most of the languages they offer the floating point type, and for floating point type you are following normally this particular standard. So even in C language, even with Python, fine, most of the languages, when you deal with floating point type, you will have this. What is 0 divided by 0? This is not a number. Yeah. So we call it as NaN. Not a number. Fine. 0 divided by 0 is not a number. Fine. This is fine, or we call it as NaN. Fine, clear? So special values for floating point type. Okay, so whether it may be double or it may be float, in both cases we have this. It's all about the exponent being bits being ones. Okay, if all the exponent bits are ones, then it is not representing a finite value. If all the mantissa bits are 0 with all exponent bit ones, then it is infinity. Any other combination with exponent bit 1, mantissa could be any combination, then it is NaN. They are all NaNs, not a number. They're not a number for us. Okay. And so, yeah. Actually, yesterday I told you about, like, can check out with what is IEEE 754. Right? So try that, because I did find one site where this IEEE 754 thing was there, and we could interactively actually set the bits and see what's the value, because we have all the bits, right? 32 bits or 64 bit. You could experiment with both of them and see the values. Okay, you could set them and check the values. Okay, anyway, fine. In Java also you can write the code to do that. Okay, later we can see that, right? But fine, clear? Okay. And so special values, I'll just mention special values for infinity, minus infinity, and okay, not a number. And so just a reminder here, right? So these are some other literals, and yeah, for example, let's see, let's try this here. Okay. It doesn't understand this. Okay, not in this manner. Then how? How can we do this? I want to assign a name. Okay, so we can still do that, right? By saying, okay, so we have, yesterday I mentioned about wrapper classes. Corresponding to every primitive type, there is a reference type. So here, for example, you can say use the wrapper class and say dot NA, and that should be fine. Okay, same way dot, and you'll have to write all capital. Not infinity, you'll have to actually write like this, positive underscore infinity. Okay. So same way, there's another literal for negative underscore infinity. Okay, right? So you can, you have those values readily available also, fine, by using the wrapper class. Fine. So these are constants available, special constants, special values, and constants are available from the wrapper class. Okay, another point which is, okay, now just before I go to the next point, there's one more thing, okay, super type and subtype relationships. Numeric types, okay, so the numeric types have a relationship of super type, subtype, okay. The biggest type among all the numeric types is the, which one? Super type, for that would be double, okay. Below double, what's an lower than double? Float. Okay. What's lower than float? We're looking at all numeric types. Long. Okay. What's below long? Int. And below the int? Okay. There are two of them. Okay. One is the short and other is the char. Okay. Fine. And then below short, we would have the byte. Okay, fine. Yeah, you can put the appropriate thing. Fine, but this is how the things are. This is from the point of view of assignability, right? Okay, even with C language, you find this. Okay, so if there is a byte value, I can always assign to a higher type. Okay, assigning to a bigger type, right? Char can be assigned to a int, short can be assigned to a int. Okay, fine. So here we have what we call as a widening conversion. Conversion of byte to a short, short to a int. into long, long to float, or float to double. And this is conversion, which is a widening conversion. Okay, fine. We can convert from any of these numeric types. Among these numeric types, you can do any conversion. Okay, you can't convert between a numeric type and the Boolean. Boolean is a separate type. You cannot convert from numeric to Boolean. Okay, fine. Okay. Now, one more thing is available. If we look at conversions, okay, we can conversion. So we have conversion from, okay, these are conversion from bigger. Okay, so when we say smaller and bigger, fine, we understand it's not based on the number of bits, because from that point of view, float has 32 bits only, and long has 64 bits. Okay, so it's not from the size point of view. The range of values, because this uses multi-sign exponent form, float has a higher range. Okay, now if it has a higher range, then some questions arise. Okay, less number of bits but having a higher range. Okay, so something about the floating point type. Let's look at some another aspect related to the floating point type. Okay, so I'll show it here like this. Okay, let's look at a number line. Right, we have a number line. Okay, we have a 0 somewhere here, let's say. So this is a 0. Okay, and we have got 1 over here. Right, any side you can go. Fine. My question is, how many floating point values do we have between 0 and 1? How many floating point values can we have between 0 and 1? Theoretically, infinite number of values. Right? We have infinite number of values there. So can all these values be represented by just the 32 bits or the 64 bit? That cannot be done, right? So since we are following that multi-sign exponent form, okay, fine. What it is doing is it's dividing this, okay, fine. It's dividing this range between 0 and 1 and between 1 and 2, okay, into small equal parts. Of course, that small width is very large in the sense the number of values here is too large. So it's a very quite close together, and the representable values are all very close together, but still you are not able to represent everything. Okay, now I have shown between 0 and 1, and between 1 and 2 it's the same number of divisions we are having. It's divided. Okay, fine. Now the number of divisions which you find between 1 and 2 is the same number of divisions you will find between 2 and 4. It's the same number of divisions which you will find between 4 and 8. It's the same number of divisions which you will find between 8 and 16. Go exponentially.
Yeah.
So what is happening? What is happening? What is this? From 0 to the smallest number which is possible, closest to 0, that width is very small, right? That length is very small. When I go from 2 to 4, the distance between 2 and the next float which is available to me is double the distance between What was the distance between 0 and the next float possible? Right? Same way, the distance between 4 and 8, the next representable after 4, is twice what was there for 2. Okay, so as you move away from 0, your level of precision is falling down, and it is falling exponentially. Okay, why I'm showing this? Fine, why I'm showing this? Let me. So one thing you realize, nearer to 0, not a problem. Going away from 0, so if you have large values, advisable not to use the float or the double. Do not ever use float data type. For floating point type, if at all you have to use, go for double and not for the float. Fine. The level of precision is so low. Fine. Let's see. I'll demonstrate here. Okay. Let's check this out. Okay. So you can see the level of precision now. Let's try the level of precision here. Okay. So let me say float. We'll try with float, right? Because these are only 32 bits. Float A equals, and I have a value 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, a 9-digit value. Okay, let's check what goes into float. What has gone there? Okay, let's check this out. Printf system.out.printf, and we can use percentage. We use that, right? 10.0f, okay, comma, the value a. Look at the value which is being printed, okay, and I should have put a backslash, backslash, okay, yeah. So this is what's the value. What has gone there? What is assigned into A? I was trying to put the value 1, 2, 3, 4, 5, 6, 7, 8, 9. What has happened is it has been converted to value 792 and not 789. Okay. Fine. If I put A instead of 789, let me go for 787. Let's print the value 84. After 784, the next value which I can store as a float is 792. There is a distance of 8. You know, you were saying the distance after 0 and the next representable float is very, very small. Fine, it's minus 2 to the power of 304 or something like that. Not 304, sorry, less than that. Half than that. Okay, but anyway, it's quite large, minus 37, 38. Okay, but if you go for higher value, what happens? A 9-digit number, and we find the distance is 8. 8.0 basically. Okay, and so it's advisable not to use the float type. For any scientific applications, don't go with these float or double types. Okay, do not use the float and double for any kind of a scientific application. And what about financial application? Should it be used? See, this is what's happening for float. In case of double, of course, it may not be so bad, but it will become bad once you reach something like a 17, 18-digit number, or it's very bad. Fine. After 15, 16 digits, yes, the distance becomes 1. 1 means you can't represent 10 that 10-digit number and then dot 5.5 or something. Fine. Yeah, and as you will make it a 18-digit number, then you will find the distance is high even for the double type. So for financial application, would you use float or double?
Maybe yes.
You will have problems because in financial application also, you deal with so many large amounts of, right?
Yes.
And it will be very sensitive thing. Okay, so wherever there is a sensitivity, precision is needed. Don't go and do not use the float and the double type. Okay, fine. There is actually another kind of a mathematics where you can have you use the whole number only, but with an assumed decimal point somewhere. Okay, fine. You assume the decimal point. When you multiply, what will be the result, where the decimal point will move. So that kind of thing is also available, right? So based on such things, okay, based on those, there are a couple of classes which are available in Java for use instead of this. Okay, you see with long, I said, what's the range? A 18-digit number. Now in cryptography, right? In cryptography, you are dependent on a product of two prime digit numbers, which are 100 digits. 100-digit prime numbers. You deal with such values for cryptography. Okay, what is the data type for me? Any of these primitive types will work? No. You can't be using long. Float and double, they have their problems. Okay, precision is a problem there.
Yes.
Okay, so float and double are imprecise. They are not precise. They don't have there is a problem related to the precision, especially when the value is large. Okay, smaller values, fine. Near to zero, it's very good. Okay, but as you go away from zero, it's a problem. Okay, fine. So what do we use then? Okay, so what we have is, okay, so let me put these statements there. Yeah. Okay. Okay, fine, we understand this problem of precision, right? And so clear? Okay, fine. Then what do we have? So in Java, we have a couple of okay, which are part of java.math package. Okay, and so when I'm saying java.math package, it's just the prefix. So we have these classes called java.math. Big integer. Okay, so big integer is nothing but dealing with whole numbers. Fine. For example, that cryptography I was mentioning, 100-digit prime numbers. So yeah, you want to have 100-digit, any number, whatever size you want, you can have number of that size. Okay, so large numbers can be dealt with big integer, and the other type is where you have a decimal value as well, assumed decimal point kind of a thing. So it's internally using a big integer but with a assumed decimal point. Okay, so these are the two classes which we have, okay, which are good for using with large numbers. Okay, fine. So big integer, big decimal. Okay. Okay, you can, for example, here, let's see this. We want to see what big integer. Okay, a equals, and yeah, or you could say, yeah. Okay. And here you can specify any size digits. So, I think we have to use new. Yeah. So any size numbers can be used with this. And you can easily go over 100, any size, and there's no restriction on the size. In case of big decimal, you may even use a decimal point, right? So for example, yeah, okay, you can say and you might have the, so with decimal point also. Right? Okay, fine. So this just related to the limitation for the use of primitive types. Right? Large values, you may not be able to handle them. Okay, fine. So primitive types, fine, clear on the primitive types now? Okay. Fine. Now let's talk about the reference type. Yeah. So what are the reference types? Okay. I think I was also talking about the conversion, right? So we have widening conversion. So how do we do the or I think we will talk about conversions when we look at the operators. Okay. And we'll be looking at operators also later. So, and so currently, let's move to what are the reference type. Okay, we know the wrapper types now already, right? Primitive, there's a corresponding class. Okay, so okay, so let's look at first thing, the difference between the primitive types and reference type. Okay, fine. And this is with respect to a variable. Okay, a variable of a primitive type has the value. Fine, it has the value. Whereas a variable of any reference type, fine, it could be any reference type. Okay, we can say of a reference type has fine. Okay, has a reference to an object. Fine. The variable. Now this is about the reference type. Okay, is not the object. Okay. So if I'm fine, I'll show it here. It's like this. Okay. So if someone says, okay, int, okay, it's a primitive type, int a equal to 75, right? We have space for a, this is the variable a, and this space which is for A has the value 75 inside it, right? Fine, it will have those 32 bits where the value 75 in binary form has been available. Okay, whereas if someone writes string s is equal to okay, what we will be having, oh, what is this part? This is an object of the type string. Okay, so there is an object which is created. Okay, it's available somewhere, and this object has the characters hello, right? Okay, that's my object. But that is not what S is. This is not S. S has its own space, and it keeps a reference to an object. Variable of a reference type has references to object. At any point, it can refer to a different object also by using an assignment. So if I'm, after doing this, if I'm saying S is equal to world, okay, suppose something like this is, oh, there is another object, right, which has the characters world, okay, and if I make this assignment, right, it would stop referring here and start referring to this. Right? Nothing would be done to this object. Okay, it's not that, oh, I have to fill that with world there. Okay, it's not that way. So variable of a reference type are every object has its own space. We don't know how much space an object needs. Fine. Each object will have its own requirement, how much space it needs. Okay, the variable is not the object. It's a reference to an object. That's why variable is a reference. Variable for a reference type is a reference to refer to an object. When variable refers to the object, variable is not the object. That should be clear. Fine. So basic difference is there. Here the value is in the variable. Variable has the value. Variable has a reference and not the object. Has reference to a object. Fine. So this is how we should understand this. Okay. Fine. Now default value for primitive types. What's the default value for the primitive types? Okay, fine. We'll look at default value later. Let's see. Okay, now let's start with the reference types. Right? So the very first reference type which we would like to understand is the array type. Fine. So what is an array? And multiple elements. Array is nothing but sequence of multiple elements. Okay. So here, yeah, okay, let's look at the array declaration. I think I'll put it in the text first. Okay, so let's take a simple example for an array. Okay, and some comparison we might have with C language. Right? For example, in case of C language, so okay, I'll put, okay. In C language, and our example for C language would be something like I want an array of 5 integers. Then in, let's say, variable, and you would do it like this, right? Okay, so this is nothing but C language. This is not valid for Java. Okay, yeah, it's different. Fine. I would prefer using a particular syntax and say, oh, we have array as a data type, a is a variable, okay, and it would need a, now okay, yeah, it would need a object to be created, specify how many elements, like this. Okay, so what is done here? We have a variable a. Okay, on the right hand side, fine, what it will do, create an object with 5 elements. Okay, fine. So it is through assignment that you change the reference. So you would have, okay, so we have a allocation part separately. Okay, you may declare a variable. Fine, I see one more thing here. You fine, when I have to write this, okay, I can also write as, so this, and but the earlier, this is the earlier one is what would be preferred one. Yeah, this is also valid. Okay, fine, though both are considered valid, fine, but the first one looks more logical, because we are saying, oh, I have a variable a and the type is array of integers, right? We always use type and then the name of the variable, right? This is just so that, yes, it matches somehow with the C syntax to some extent. Okay, fine. Okay, again, so what now my question is, when it allocates those 5 integers, fine, what will be the initial value for the 5 ints in the array? That array has 5 integers. What is the value in each of those integers? Default value should be, it's an integer type. Okay, fine. For numeric types have a value of 0. Array elements for Boolean type have a default value of false. 0 is false, 1 is right? Okay, and array elements for we may have an array of a reference type, array of a string type, for example. And what is the default value they will have? Okay, so there is a value called null which is applicable to the reference type. It's not for the numeric type. Okay. So if we say string s is equal to null, okay, suppose we put like this, okay, it would mean s is not referring to any object. I'm not referring anywhere. Fine. I don't have a reference to an object. And so there's no object available from S because we have set it to null. So null means not referring anywhere. Fine. So clear about the reference, the meaning of a reference. Fine. It has to refer somewhere. Okay. Now, for a few things about the arrays now. Fine. For any array type, okay, array type means it has a number of elements, right? So for any array type, we can find the number of elements. Okay. For any array type, we can know the number of elements by using the length. Okay. Okay. Example. And we can even use constants like this. Okay. So whatever the number of values may have been there, right? So suppose this is something what you have done. You can say what is a dot length? Okay, system out println. So you can find the, so length is what you can use to fetch the number of elements in available for the object available from A. So A is a reference to an array object. Okay, how many elements does it have? So that's what you can do here. Okay, fine. And later A may refer to a different array. When someone says, so, oh, let me assign new int. I want to have an element array of size 10. Yeah. You can ask for a dot length again. Okay.
Now in this case, what will the output?
The second one will be saying 10. What's the output for the first one? We'll have to count 3, 4, 5, 6, 7, 8.
Okay.
8, fine? 8. There are 8 elements. Fine. So we can write constants. One more thing about this assignment, okay, which I'll have to show here. Okay, and so I'm just showing it again. So this is fine, but suppose I do like this. You know, many times we may just declare, right?
Yes.
And I want to assign later. So while assigning in the same line, fine, while assigning, if I'm assigning a array constant, that is a constant means using braces, okay, it is fine. But if someone writes like this, okay, so that would be an error. Okay. So instead of this, yeah, if you are assigning later, what you will need to do is you'll have to mention. Okay, you'll have to say new int array.
Okay.
Right? Then this is not an error. Fine. So this is what needs to be done. Clear for the array types. Fine. I have shown with in general any array type. Okay. Fine. Want to test this case? Okay. Let's test the case of assigning a array literal. So we have int array A equals, and in braces, okay, and so this works. What if I just declare int array A? Okay, and it has anyway set it to null. A is null, not referring anywhere, so that's okay. But now if I say A equals, and let me put fine. Whereas to make it work, I'll have to say, I'll have to declare what type it is. Okay. New int array. Now this is fine.
Clear.
Okay, you'll have to mention by saying allocate a new integer array with this. But if you are doing the declaration and assignment in the same place, then it is fine. Okay, this is fine.
Yeah.
Declaration and assignment, fine. This is declaration, int array A. Assignment to a constant, then this is okay. Okay, so any type of any data type could be used for creating a array. So you can have array of any type. Okay, so yeah, now what about the two-dimensional array? We think it as two-dimensional array normally, right? Okay, one more thing before going to a two-dimensional array. Yeah.
Two brackets.
Okay, use two square brackets. Okay, yeah, that's how we do in C language also. Here also same thing. But before going into two-dimensional array, let's take an example for a array of a reference type. Okay, let's look at the example of array of a reference type, and this we'll have to visualize. Okay, so let me show it here. Okay, fine. So let's say I have instead of this, let me use a string array. Okay, we create a string array. So again, for a string array also you can do something like this. String array. Okay, fine. S is equal to, and yeah. Okay, we can either use those braces, and then in braces we use double quotes, or let's go ahead and use the assignment new string. And let's say I have 5 elements. Yeah, so what happens when I do this? There is space for the variable s, and it refers to an object. This object has got 5 elements. Okay, so there are 5 elements in the array referred from S. Okay, fine. So what's there now? If I am saying, okay, now if I am saying S of 0, right? We can refer to S of 0. Okay, fine. I'm assuming we know this, that how arrays are used. Square bracket indexes. Okay, so if I say S of 0 is equal to, what can I assign there? Strings. So you'll have to use double quotes. So S of 0 is equal to hello. Okay, suppose this is what I have put, then what would be done? Where is this object? Where is this value hello? It is an object, right? It's a string object. Okay, so you would have a string object like this. Okay, that's my string object, and this is my S of 0. What is S of 0? What's the type for S of 0? String. It's a reference type. It's a reference type. That means what is S0? It is a reference. Reference which will refer to this. This is S of 0. What is here, 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 and here? They are initially null.
Okay.
Fine. So when we allocate an array of a reference type, it is only allocating the references. There are no objects
Okay.
other than the array object itself. Okay. Fine. So if I say new string 5, there are not 5 string objects. There are 5 references. They can refer to some string object. Fine. Okay. Fine. In another case, it could have been something like string array S is equal to, and someone might have used braces and said, okay, let's have something like this. Okay. So what would have been done if someone tries this? It would have variable S referring to an array with how many elements? This would have only two elements. Okay, S refers to this, and let's pull it up, and we would have one object of hello, and S0 refers to this. We would have the other object of world, and S of 1 would refer to this. Okay. One important point about arrays is arrays have a fixed size. Any array object has a fixed size. The object, I'm talking about the object. This object cannot be made to extend or reduce the size. Any array object, right? This is my array object here. Okay. So this array object cannot be changed to that. The reference S can refer to a different object. So your S is simply a variable referring to some, at any point of time, it would be able to refer to an object which is of the type string array. It cannot refer to any other type of object. S will not be able to refer to anything which is not an array of string. When we are declaring a type for a variable, that means, okay, it's a reference type. Yes, I'll be referring to object, but which type of objects? And you cannot be referring to a string. You can refer to an array of string. Okay, fine. Someone saying, after having done this string array S is equal to hello world, if after this someone says S is equal to and says, let me say hello world. So that's an error, compilation error. The type for S is not string. The type for S is array of string. So this is not valid. Okay, fine, not valid. Clear? Fine. Reference variable, they will have a type to indicate what kind of object it will be able to refer to. Okay, fine. Now, so this is array for a reference type. That should be clear. It allocates references. Now we can go to understand the two-dimensional array kind of things. Okay. Okay. So let me start with a small example here. Fine. So we start with a two-dimensional array of integer type. Okay. So you might have a, so you can declare like this: a equals, you can say new and int, now in square bracket. Yeah. Okay. So I can specify size. You know, you have to specify size. So for the first one, the size is compulsory. You'll have to specify. You can specify the second size also. You can say, okay, 10 and 5. Okay, so let's say this is my first statement, and then I'm saying what is a dot length. Let me put system dot out dot println what is a dot length. Yeah, what should be a dot length?
50.
It will print 10. Okay, let's understand this, right? What is a two-dimensional array? Okay, fine. Now one thing, what's the type? So what is the type for the following? Fine. What's the type for A? The type is int, two-dimensional array. What's the type for A of 0? What's the type? Int array. It would be the single dimensional array. And what's the type for A 0? 0. This type here is int. Right? Here A0 is a reference type. Fine. What has been done when we did this statement? Okay, when we do this statement, okay, fine. It first allocate. Let me do this. Okay. Ten references. Okay. For of type int array. They are arrays. Okay. Each of the references in turn refer to an int array. They are of type int array of size 5. Okay. And the picture is like this. Let's check this picture. So we are looking at int array, two-dimensional. A equals new int 10 5. Okay, fine. We are looking at this. So first thing is, yes, we have reference A. It would refer to an array with how many elements? 10 elements. It is allocating 10 references, right? And each one is an array. Okay, the elements are of type array, right? See, it's array of, see, this is nothing but array of the type int array. Clear? Array of the type int array. So the elements are of type int array here. Fine. Here. This is the elements here are of type int array. And here is the int array. This array has 5 elements. So same thing. So now you can see a dot length. How many elements? A dot length? A dot length. 10. A 0 dot length. This is a 0. What is a 0 dot length? 5. Okay. Fine. A 0 dot length is 5. A dot length is 10. A 1 dot length? 5. Okay. Now, after this, if someone says a of 0 equals new int 7. What would be done? Another array, new int 7. Oh, this has got 7 elements. Okay, and you stop referring here. Let me now start referring to this one. So what is a dot length? 10. What is a0 dot length now? 7. What is a1 dot length? a1 dot length is still 5.
Okay. Now I clear.
Right? So each row can have different number of columns.
Okay.
That is the whole point.
Yeah.
Fine. Each row can have different number of columns. We are looking at it from row and column point of view. Fine. You want to iterate over all the elements of such an array. Fine. Let's see how we write the code. You want to go over all of them? Okay. So let's check this. Clear references. This is just a reference. We refer to a different value at different point of time. Okay. Okay. So we have here. Okay. So let me specify. So this is what we have done, right? Size 5. Yeah. Now, if we make, even this thing is also fine. And someone starts like this. This is also okay. And he says, okay. So 2 dimension. See, different sizes. Okay. And each element has its own array.
Okay.
Right? So now here, if I can say a of a dot length, I have got how many? 3. Fine. A of that length is 3. Okay. A of 0 dot length, that is going to be 4. Okay. A of 1 dot length, that's 2. Okay. Fine. Clear. So this clarifies,
Okay.
right, that each element, fine, in the second dimension, second level. So it's 3 levels, right? First is a, second level is a of I, third level is of a of ij.
Okay.
Okay. You want to go over all the elements. So there is an array, and I want to go over all the elements. Okay. For int I equals 0, I less than a dot length. Okay, within which I'll be saying for int j equals 0, j less than, what should be j less than? A,
I,
a of I.
yeah,
Okay, within this, then I can say, oh, I want to put a of I of j equals, let's say I want to make it I plus j. Fine. Let's not worry about what was done here. Okay. Or fine. Okay. Let me put it as a separate example. This one. Okay. But this we understand is how this is a standard way by which you can iterate over a 2-dimensional array. And we can iterate over the 2-dimensional array. But what we can always suppose we before this, now let me put a few code here. I'll say, okay, I'll start with this a equals new int 10 and 5. Okay, so we have this code, And next statement, look at the next statement. What I'm now doing is I'm saying A of 2 or A of 0, you can say. A of 2 equals A of 0. The type is, they're both reference type. So you're saying change the reference for A2 so that it becomes same as A of 0. They both will refer to the same array. Okay, now my question here is, what will be the output if I write the system.out.println A of A0 and 3. A0, 3. What is A0, 3? A of ij is I plus j. That's what we have done. But don't ignore this statement. What is A03? The question is, what is A03? Okay, fine. So I'll leave this as a small exercise for you. Fine. So find out and find the reason why. Okay, how it happens like this. Okay. The important thing is to understand that this particular statement. Right? So anyway, I'll be pushing this code. Okay, this in the notes. Fine. So you should be able to see this. Fine. So fine. We'll continue tomorrow.